When listening to studio monitors or performing music live, not everyone thinks about all of the parts in audio chain that affects the sound. So this time I would like to take a look at very important audio component in audio reproduction, the power amplifier. It often gets overlooked as its job is to simply amplify the incoming signal, and the outgoing signal should be exactly the same as the incoming, just louder. But in practice, it's not. In practice, there are distortions, sometimes lack of bass for some reason, and lack of dynamics, and even added noise floor, and sometimes even high frequencies are rolled off. And actually measuring quality of amplifiers related to their distortion is a bit tricky as well, because some people, especially certain type of audiophiles, expect the outcoming signal to be a bit warm or lightly distorted. Otherwise, for their tastes, it sounds too lean, but actually it could be simply neutral. But anyway, if you are making music, it would make sense to know how different amplifiers affect music and how to make less biased decisions and know what to expect if it will be played with something else. For example, it might be surprising when playing with a better amplifier at loud volumes. Music sounds suddenly a lot better because it's less compressed, because you are not reaching the limits of this amplifier. And amplifiers are divided in these classes with letters. For example, class A is the purest way to amplify a signal. You can imagine it as simply drawing a bigger sine wave than the one that's coming in. And class B would be like drawing two half waves and then gluing them together in one. And then there is class AB that would be like drawing a little bit more than half of the wave and then gluing them together smoothly. So class AB amplifiers mainly consist of transistors. For example, here you can see beautiful four large Toshiba transistors, and each of them give out something like 50 watts of power. And for an amplifier like this, it's very important to have clean power. That's why we have right here a toroidal transformer that is a lot less noisier and is harder to manufacture, but does create a nice, beautiful stream of alternating current. Then there is class C, that would be like drawing less than half of the wave and then trying to glue these parts together again. Also very interesting one is class D. And class D would be like drawing, instead of waves, a pulse wave and then filtering it out till it turns into a sine wave. And class D amplifiers, of course, can be chips, they can be discrete. For example, a box like this is very powerful, more powerful than that transistor amplifier, although it's a lot smaller, because it's based on a chip that is not digital, it's analog, and it's not so dependent on the the power supply. That way we can use something that is even external and is maybe sometimes even bigger than the amplifier itself. For example, this is a power brick that is laptop style power brick, which is a switching power supply, very powerful. It's 216. There are also other interesting classes like G and H that are simply enhancements to class AB design with slight increases in efficiency. For example, if you add a delay to music or a signal that is coming into amplifier, you can gauge what kind of power and in which direction do you need, and therefore make a better, more efficient decisions. Actually, in technical sense, amp classes are actually related to the degrees of conduction. So if you meet someone with electrical engineering degree, maybe he or she will say that in classical theory, There are only three classes of amplifiers: A, B, and C. For class A, conduction angle is 360 degrees. For class B, it's half of that, half cycle, 180 degrees. And for class C, it's slightly less than 180 degrees. And that's it. Circle does not have any more degrees. You'll probably see heavy toroidal transformers more often in Class AB and Class A amplifiers, as they are largely defined by their power supplies. And if it's a budget product, it might have these EI transformers that can buzz and hum by themselves. So some manufacturers put like glue on top of it or try to somehow hide it. And it also produces a little bit worse sound, as well as it's less efficient. You will often see Class AB amplifiers on older subwoofers, high power pro audio amplifiers for large venues, and in most flagship audiophile amplifiers. Although everything is moving towards a lot more efficient and neutral sounding Class D, for the longest time it's been a lot easier to get better bass and cleaner sound and even more musical sound on Class AB amplifiers because of their sturdy, powerful, time-tested, mature design and many other things. Class D amplifiers would need to get their power supplies right to get as good bass as in Class AB. For example, sometimes you would need to buy an additional input buffer board to get sufficient power for the Class D amplifier with the right impedance. Also, in these days, Class D amplifier sound can be greatly improved with these switching GAN power supplies. And often you will notice actually that Class D amplifiers use switch mode power supplies, as Class D is all about efficiency and filtering out everything that you don't need. And if you can achieve that, probably you can also filter the noise out of switching power supply. To gauge the quality of bass, one of the simplest measurements that you can do or check out is a simple square wave amplification in bass region, let's say from 20 Hz till 100 Hz. Usually the lower it goes, the more jagged and distorted it is. But it should be nice and straight. And actually, in these days, there are a lot of Class D amplifiers that outperform even classic AB amplifiers in this specific test. But the most notable problem with most Class D amplifiers is that they start to distort very heavily before they reach their advertised power. That's why they have this bad name, and also because most of them are based on a chip, and this chip usually performs bad in this square test, and also sometimes it doesn't even reach half of its power and it's already distorting very heavily. But if you don't play music loudly, like in the studio while producing music, it's fine. It might be a more noticeable problem when you're trying to entertain a crowd at an exciting loudness. But this is why you should check the original datasheet from manufacturer. If it is a chip-based Class D amplifier, then popular Class D chip manufacturers are Texas Instruments and ST Microelectronics. And while checking the THD, total harmonic distortion measurements in these datasheets, you can gauge where approximately you should play this amplifier and keep the signal clean. You should also check if the power supply is powerful enough to support this amp if you will buy the power supply separately. For power supplies, you can simply multiply the amps with volts to get the wattage and check the acceptable voltage range for this amp. It is also possible that your active studio monitors have a stereo or two separate mono amplifiers built into it, and they might have different distortion characteristics as well. Although the speakers are the first thing to distort, especially around the ends of usable frequency range for each driver. And the distortion is usually pretty high, it's like over 10%. Amplifier distortion can also trick you into believing that the sound is warmer than it actually is. Some studio monitor designers include multiple amps because there are benefits of having a separate amplifier just for the bass, as it will need most of the wattage. And if it's a three-way system, they might add a separate smaller amplifier to midwoofer and tweeter, so at loud volumes it will actually not distort so much in highs and mids, but your bass will start to get suspiciously warm. Some studio monitors even have DSP modules that process the crossover in digital form, so the incoming analog signal gets converted into digital, processed, and then converted back into analog in multiple channels that can be afterwards amplified separately. This is of course unfortunate because if you are using an expensive DAC or audio interface with expensive DAC in it, it gets overwritten by probably a low-cost DAC inside of your studio monitors. Class D amplifiers, in practical sense, actually have many advantages. For example, they take a very small footprint that is very convenient. You can put it in small enclosures, in bookshelf speakers, or in small boxes. Of course, if it's a decent non-chip based discrete Class D amplifier, it will need more space, of course. But then again, maybe the heatsink will not be so big, because also a huge advantage to Class D amplifiers are that they are so efficient that they don't produce so much heat. For example, Class A amplifiers, on the other hand, are so inefficient that they are often not practical. They waste too much power and often need large active cooling, as they turn all energy that does not produce sound into heat, while some powerful Class D amplifiers barely need a heatsink, and they hover around 60 degrees or so at full load. Examples of good Class D modules that you can find in different amplifiers or make your own would be like the ICE power modules that are very convenient, as they have already their own power supplies built in, and they reach even 1200 watts, for example. Then there are these very great Purify Class D modules that are receiving rave reviews, that you can get in these modules that fit with this nice balanced input boards, and you can also upgrade them with these input buffer boards from Neurochrome. Then another good option is the Hypex Encore amplifier modules. And for these modules, actually you can find also a cheap clones that can produce very clean amplification at high wattage. And that's pretty much it. There's actually a lot of interesting things related to amplifiers and how they color the sound, how it's affected music. But for now, as a basic overview of amplifiers, I think we're good. Thanks.